Hello, let's continue our Sudoku adventure with Zipsaw puzzle by Wuschel. So we have normal irregular 6x6 Sudoku rules. So we still, in every row and every column, are placing the digits 1 to 6 exactly once each. But our normal 2x3 boxes aren't present. Instead, we have these irregularly shaped regions. There's still 6 of them, and they're all 6 in size. And we are putting the digits 1 to 6 exactly once each into them. So this region, this region, for example, this one, right? So they work just like boxes, they just aren't shaped like boxes anymore. All right, in addition to that, we do have these lavender lines, which are called zipper lines. The way this works is whatever the center digit ends up being, like let's say this was a 5, the 2 digits that are equidistant from that center sum to that center digit. So this could be like 2, 3, and this could be like 1, 4, because these are equidistant, and then these are equidistant, so this could be 2, 3 again. This way. That doesn't work at all. Oh well. But you get the idea. So these add to 5, these add to 5, these add to 5, or whatever is filled into the center. All right, and that's it. Those are the rules. There's a link in the description if you'd like to try the puzzle yourself, and I'm going to get started right now. Okay, I am noticing that these are all in the same region. We definitely had trouble filling this out. I think I might do some coloring first, though, because there are certain geometries here that are very important. So by coloring, if you haven't encountered this strategy before, what's really nice about Sudoku Pad is it does let you color cells, pretty much any color you want. So I'm going to make this cell green. And green is like a variable, right? It's going to represent whatever this digit ends up being. We don't know if this is 1 through 6. Well, we know it's not 6 because zipper lines, you can't put 6 on any of these because what would you do? Like 6 plus 1 is what to fill in here? Anyway, we don't know what digit this is, but we do know we're going to call that green. So whatever in this, if you were to look at the solution of this puzzle, green would be the digit that goes here. And so we know there's 6 greens in the puzzle, and we know they can't repeat in rows, columns, and boxes, or regions, I should say. So this region has a green, right? Think about it. It's got 1 through 6 in it. So whether this ends up 1, 2, 3, 4, 5, 6, it will be in this region somewhere. And there'll be exactly 1 green in this region. So where is it? Well, it can't be in the same row. So it's either here or here. But I will say it cannot be the center of this zipper line, because then we'd have to do green plus 0 is the center digit. So this is the only place green can go. And so now we know that this digit is an even number, 2, 4, 6. I think 2 doesn't work though, because we can't do 1 plus 1 here and 1 plus 1 here. So 2 doesn't work. But so this is 4 or 6, and these are going to be 2 or 3 only, because this is either 2 plus 2 is 4 or 3 plus 3 is 6. Now, I suspect it's 6. Let's see if we can get away with 4, though. So if this was 4, let's just write this out in little numbers. This would be 2 plus 2 equals 4. So now I've got 1 plus 3 as an option, and this can't be the 2. So we can't do 2 plus 2 here. In fact, we can't put any more 2s in here. So this would be a 1, 3 pair, and this would be a 1, 3 pair. And to be honest, I think that works. So one option is to have 1, 3 pairs here and here. That this 1, 3 pair would sum to 4. And this 1, 3 pair would sum to 4. The other option is to do 4 plus 4. Oh, sorry. 3 plus 3, sorry. I was confused. 3 plus 3 is 6. And then we couldn't repeat a 3 in here, so we can't do more 3 plus 3s. And so we would be 1, 5, and 2, 4 as our options. So that would be pretty free. So yeah, I don't know how to restrict this further. Now, I guess we could see if green can extend further. I'm not sure. Okay, one thing we do know, though, we can do another color. I'm going to call this purple. We know that purple is not green. So I generally only will give a color to another cell if I know it's the same color, like I'll give it the same color because I've proven that, like that. Or I know it cannot be any of my other colors already. So purple is a non-green digit. And purple needs to go in this row somewhere, and it cannot repeat in these cells. So purple ends up here. In fact, we could have used that to prove green without needing to deal with the with this region. We could have used this row to prove green was there. So that would be another way to do it. So purple and green go in here somewhere, but I'm not sure where. I'm not sure that this is immediately helpful. Green is in here somewhere. 2 or 3, though. So we know this can't be green because this can't be 2 or 3. That would be way too small for the sum of 2 digits. 3 technically can be 1 plus 2. Would that work? Okay, let's just experiment here. If this was 1, 2, this would be 1, 2. Oh, because of this region, that doesn't work. Okay, so is there any other way to do it? So I would need 1 plus 2 like this. And then this would be a 1, 2 pair. This would be 1, this would be 2. That does work. Okay, so this could actually add to 3, so it could be green. Darn. That's not limited at all. Is there any reason this couldn't work? Not that I see. How are we doing this then? How are we getting digits here? We know that these 2 digits are not purple, and so they don't go in the rest of the, like, let's give this blue and orange. And now normally I just said I wouldn't give a color unless I could prove it wasn't all of them. We know it's not purple. We don't know that these aren't green. So I'll just say that ahead of time. But I just want to point out this geometry here. Whatever these 2 digits are, they can't repeat in this row, and we know they aren't purple because they share a row with purple already. So they end up here in some order. I'm wondering if there's some region we can assign a different color to each cell in the region and then propagate them that way. That's kind of what I'm thinking about at the moment. I don't know what a good region would be for that, though. This region, maybe? Okay, yeah, so we don't know that this isn't purple, so I'm going to get rid of this purple for now. Let's just call this blue, though. This blue cannot go here and cannot go here, so it ends up here in this region, and that proves that it is not 6. Because again, you can't put 6 on this because it would be 6 plus what equals this. 6 is already the biggest digit. So actually this ends up being 4. And now that it has a name, we don't need a color for it. So we know it's 4, we don't need to call it blue. And now that that's 4, these are 2s, and I don't need colors for those either. Okay, I'm going to make these purple again, just to remind myself that those are the same as each other. So this has to be 5 or 6, and this is 1 or 2, because 4 plus something equals this digit. Oh, and we found that these had to be 1, 3 pairs, 1, 3, 1, 3, and so then this is 5, 6. And I can color the 1, 3s as well, so which means I should get rid of the purple, actually. Let's just call these blue and orange. And we know that blue plus orange is 4, so we need to do blue this way, because we need this to be blue plus orange and this to be blue plus orange to make 4. See if that's helpful at all. So that does mean blue is one of these 2 cells. They're not here, here, here. Blue's one of these 2. How about this column? Blue's in one of these 2, because this blue can't repeat here. See, I don't know that this isn't orange. That's the problem. I can't give this a color now. So these add to 5 or 6. I don't know what to do with that. If this was blue, this would be 1 plus 4 or 1 plus 5. Or 3 plus 2. There's obviously more I can do here. It's got to be more irregular geometry. So let's actually fill that these are 2, 5, 6, and that's not a 2. So the 2 is one of these. That's a 5, 6 pair. So these are 1, 3, 4. That's not a 4. So if that's a 1, 3, 4 triple, then these are from 2, 5, 6. Now this can't be a 6, as we talked about. So this adds to 5 or 6. So if this was a 2, this would be a 3 or a 4, but it can't be 4. So if this was a 2, we would add to 5 with 2 plus 3. If this was a 5, this would need to be a 1, and that would be 5 plus 1 is 6. Now, that does mean that one of these is always 5, right? Because either this is a 5, in which case, yes, it's 5. Actually, let's look at this. This is either a 5, in which case, yes, this is 5, or it's a 2, which forces us to do 2 plus 3 is 5, because we can't do 2 plus 4 is 6. So either way, one of these ends up 5. There's no world where this is a 2 and this is a 6, omitting 5 entirely, because we can't put a 4 here. That's another way to put it. So 5 is one of these, which means in the region it can't repeat. So this is not 5. What else can we learn here? This is intricate. This being 1-3 makes me think it's blue, but honestly, it could also be orange. But it is definitely blue or orange. We just don't know which. Is there anything else I can do here? 2 is in one of these 2 cells in this region because it's not here or here. Try this too. Okay. This is a 2, 5, 6 triple. I just noticed that. So that means this is the remaining 3 digits of 1, 3, 4. It's another 1, 3, 4. Interesting. Okay. This is also 1, 3, 4 because remember these are the same digit. Okay, if it was 1 or 3, it would be orange. So it's orange or 4. If it was orange, this would be blue. And that, oh, this is a 1, 3, 4 triple. So this is 2, 5, 6. Is there more geometry I'm just not seeing here? Ah, but it can't be 5. These 5s point. I was going to say, this. Where does this digit go in this region? And it's this. These are the same digit as each other. Well, we know for a fact that these aren't blue or orange or 2 or 4 because they're 2 or... Oh, sorry, no, they could be 2. What am I saying? Ah, they could be 2. But I could give them a color because they aren't blue or orange. You know what? I've been thinking about these as purple, so let's not make it that purple. Let's reuse green here. Just trying to see if green can be used here. Do we have any other, like, we got this pair. Ah, we have the 5, 6 pair and the 1, 3 pair. So the question is, where does 4 go? It goes here in the row. I think it's just a lot of scanning here. This is 2, 5, 6. This can't be the 2. So then this is also 1, 3. So this is an orange-blue pair. And the rest of this column is 2, 5, 6. The 2 can't go here or here. So the 2 ends up there. That's great. That makes that a 1. That means this is 4 plus 1 is 5. Which means this is 2 plus 3, and that's a 1. And I still don't know. Ah, but I know that blue is 3 now. Very nice. Okay, so now I can get rid of all of my blue oranges. And these are 6, and so we don't need to call those green. So I don't think we need coloring anymore. That's 5, that's 6, that's 2. That's a 5 and a 6, that's 5. We get our 3, 4, and 1. We get the 3 here. That's a 4. 5 and 2. That's a 4. Now we just plonk the rest of the digits. This is a 6. This row, we need a 1, which goes there, and we need a 3. Then down here, this is a 6, this is a 5, and we're done. Wow. So yeah, it was just a lot of irregular scanning, some interesting pairs and triples that appeared. So yeah, cool. Probably the 4 in this row is what I missed for the longest time. Yeah, we could have seen that with geometry, because where do these 2 digits go in this row? They end up here. So we would know that these 2 digits were these 2. Might have been a nice way of shortcutting some things. So I'm sorry I missed that for so long. Hope you enjoyed this, and if you did, then why not leave a like, subscribe, and a kind comment below.